In this video, we're going to look at graphs of the function sine x plus or minus a inside the bracket and cos x plus or minus a inside the bracket. And these graphs shift vertically left to right. So in this example, we want to write down the equation for the graph in the form y equals sine x plus a when a is inside the bracket. So this affects the x coordinates. So the first thing we want to do is consider the key points for our y equals sine x curve, and it would start at 0, it would go up to 91, it would be at 180, 0, 270, -1, and back up to 360, 0. So we can see that the curve in our diagram, our y equals sine x plus a curve, has shifted from its original position to the left. So we're going to consider the roots because we've been given the roots of our y equals sine x plus a curve. So the two roots that we want to look at are 180, 0 and 360, 0. As it's moved to the left, our 0, 0 is no longer within 0 to 360 degrees. So on our y equals sine x plus a curve, these roots are now at 160, 0 and 340, 0. So we need to set ourselves up an equation to solve for a. So we know that if we replace our x coordinate with 160, that 160 plus a is going to equal 180 degrees. And if we solve for a by taking 160 degrees away from both sides, we get a equals 20. We can then double check that this works with our other coordinate, and if we do 340 plus 20, we get 360, which was our original key point. So the equation of this graph is y equals sine, and inside the bracket, x plus 20 degrees. Now we can see in this next example, we want to write down the equation for the graph in the form of y equals cos x plus a. So again, we want to consider our original graph, which would start at 0, 1. It would go down to 90, 0. The minimum's at 180, -1. Our next root is at 270, 0, and it would finish at 360, 1. And if we just sketch that curve in, we can see that this time our y equals cos x plus a curve has moved to the right of its original position. So again, we're going to consider the roots that we've been given on our y equals cos x plus a curve and compare them to our key points on our y equals cos x curve. So on y equals cos x, we've got a root at 90, 0 and another one at 270, 0. So then we're going to look at those roots on y equals cos x plus a when that plus a is inside the bracket affecting the x coordinates. And the two roots we've been given on this curve are 120, 0 and we've also been given 300, 0. So we want to replace the x coordinate in our bracket with 120 and do 120 plus a equals 90. To solve for a, we're going to take away 120 from both sides, giving a equals -30. And then always double check with your other coordinate. 300 minus 30 does give us 270, which is our key point on our original curve. So the equation of this graph is y equals cos x minus 30 inside the bracket. So in this example, we want to write down the equation for the graph in the form y equals a cos x plus b. You can see we have an a in front, which is our multiplier for our y coordinates, and we've got a b inside the bracket, which is going to affect our x coordinates. So let's consider our y equals cos x curve. So the key points, it starts at 0, 1, goes down to 90, 0, minimum at 180, -1, another root at 270, 0, and finishing at 360, 1. So if we just sketch that in, we can see that our y equals a cos x plus b curve has shifted vertically to the right. We can also see that our maximum and minimum values have stretched away from the x-axis and that's where the y equals a cos x plus b comes into play. So for this, we need to consider all of our key points on our y equals cos x curve. So our cos x curve started at 0, 1, it moves to 90, 0, minimum at 180, negative 1, another route at 270, 0, and finishes at 361 on a maximum. And we need to consider the key points that we've been given on our y equals a cos x plus b curve. So on the graph, we've been given two routes, one at 135, 0, which corresponds to our 90, 0 route on our original curve, and we've got 315, 0, which corresponds to our 270, 0 on our original curve. So we're going to set up an equation to solve for b. We're going to replace the x with 135, and 135 plus b is going to equal 90. So if we take away 135 from both sides, we're going to get b equals negative 45. Now remember to make sure that this works for your other route, and if we do 315 take away 45, we get 270, which is the key point on our original curve. Now we need to work out what our a value is, and this is the stretch. So our maximum and minimum values on our y equals cos x curve are 1 and negative 1, but you can see that if we put in the key points that haven't been marked on our y equals a cos x plus b curve, we have 45, 4, 225, negative 4, and as the curve has shifted to the right, our 361 is no longer in the domain. So a equals 4, as we've multiplied all of our y coordinates by 4, and that gives us an equation of y equals 4 cos and x minus 45 degrees in the bracket. So far we've been asked to determine the equation of a curve. This time we're being asked to sketch the curve y equals 3 sine x plus 45 for the domain 0 to 360 degrees. So the first thing we want to do is we want to consider our key points on our y equals sine x curve. And we're going to multiply all of the y coordinates by 3, and we're going to subtract all of the x coordinates by 45 degrees. So this means that for an x plus 45 degree shift, we're going to be moving the curve from its original position to the left. So for y equals sine x, our key points are 0, 0, a maximum at 91, a root at 180, 0, a minimum at 270, negative 1, and final root in this domain of 360, 0. So let's look at our y equals 3 sine x plus 45 degree. So the first thing we're going to do is look at our x coordinates, and in order to solve for these x coordinates, we're going to have to subtract 45 from each of our coordinates. So that's going to give us negative 45 for our first coordinate. We're going to get 90 minus 45 is 45 for the second coordinate. Our 180, 0 is going to go to 135. 270, negative 1 is going to go to 225. And our 360 degrees is going to go to 315. So they've all shifted left by 45 degrees. Now we're going to consider the y coordinates. We're going to multiply them all by 3, so we get 0, 3, 0, negative 3, and finally 0. So now that we've got our key points, we're going to mark out our scales every 45 degrees evenly using a ruler on our x-axis. So we've got 45, 90, 135, 180, 225, 270, 315, and 360. We also need to mark up our y-axis, and we've got a maximum of 3 and a minimum of negative 3. Again, use a ruler to make sure that these are evenly spaced from your x-axis. Now, if we look at our key points, the first point is out of our domain. Our domain is between 0 and 360, so we're going to plot 45, 3. We're going to plot 135, 0. We're going to plot 225, negative 3. And we're going to plot 315, 0. Now you can see that if we were to join these points up together, we would have a bit missing at the start and the finish. And in order to work out what the values are at x equals 0 and x equals 360, we're going to use a calculator and put in 3 sine 0 plus 45 is 3 sine 45, and that gives us a value of 3 over root 2, or if your calculator doesn't do surds, 2.12. So we can plot that at x equals 0 and x equals 360 and mark it on our x-axis. And then we're going to join these points beautifully together with a nice smooth curve, seeing that the start and end point are level, and then we're going to label our curve with our y equals 3 sine x plus 45. So the next curve we want to sketch is y equals 2 cos x minus 30 between 0 and 360 degrees. So again, this time we're multiplying all of our y coordinates by 2, and because we've got x minus 30 in the bracket, it's affecting our x coordinates, and to solve for x we're going to have to add 30, meaning that our y equals cos x curve is going to move to the right. So let's consider our y equals cos x key points. We start at 0, 1, we go to 90, 0, our minimum's at 180, negative 1, we have another root at 270, 0, and our maximum value is at 361. So first of all, we're going to consider for our y equals 2 cos x minus 30 what happens to those x coordinates. And as we said above, we've got a right vertical shift, so we're going to add 30 to each of those coordinates. So 0 plus 30 is 30, 90 plus 30 gives us 120, 180 plus 30 gives us 210, 270 plus 30 gives us 300, and 360 plus 30 gives us 390 degrees. And then we've got a y equals 2 cos x minus 30, so we're going to multiply all of our y coordinates by 2, so we get 32, 120, 0, 210, negative 2, 300, 0, and 392. And that final coordinate is out of our domain, as it's beyond our 360 degree limit. So we need to split up our x-axis. We're going to split it up into 30-degree intervals. Please use a ruler and evenly space these out across your x-axis. And we're going to label them every 90 degrees as 90, 180, 270, and 360 degrees. Then we need to make sure that we mark our y-axis. We have a maximum of 2 and a minimum of negative 2, and we're going to mark that onto our y-axis. Again, use a ruler to make sure these are evenly spaced. Now let's plot the points that we have on our y equals 2 cos x minus 30. So the first one is at 32, then we've got a 120, 0, 210, negative 2, 300, 0, and again, if we were to join those points up, we would have something missing at the beginning and the end at x equals 0 and x equals 360 degrees. So by using a calculator, we're going to put in y equals 2 cos negative 30, and that gives us a value of root 3, or 1.73 if your calculator doesn't do surds. And we're going to mark on 0 root 3 and 360 root 3 and label our x-axis with that root 3. And then we're going to join up all of our points with a smooth curve, making sure that our start and finish values are level, and label it with y equals 2 cos x minus 30.